Welcome everybody, thanks for coming. I know it's lunchtime. Hopefully we'll get a few more people in here, but if not, we'll still have fun. So, welcome to my talk. Quick overview of what we're going to be talking about today. A little bit about me. This is my third time presenting at LastCon, one of my favorite conferences, so super excited to be here. Been doing this some way, shape, or form for about 17 years. Started off as a full stack developer. 17 years ago, we didn't call them that. It just meant I did everything from Fortran to Delphi to databases to middleware and everything else. Super passionate about AppSec, DevSecOps, and everything that I do. Kind of core to my philosophy on AppSec and DevSecOps. Just what this talk will be all about today is developer enablement. I'm a big believer that when the secure path is the easy path, it's the path that will be followed. And I always joke that we have to make security easier than going to Stack Overflow, because we all know how well any of us can develop without Stack Overflow. A couple of fun facts. Married my high school sweetheart, still with her, 3 lovely kids. I love hiking, playing video games, play guitar. Super excited right now, big Final Fantasy 14 fan. We've got a big expansion dropping in a couple of weeks, and Amazon is finally launching the TV series for Wheel of Time. So if we have any big fantasy book nerds, super excited about that. So my thesis for today, this kind of ties in a little bit to what Jeff Williams talked about earlier. I'm convinced he stole a little bit of this from me. Believe that shift left is an outdated sentiment, and it's no longer relevant. It has developed into a culture that primarily exists to punish developers. I'm a big fan of this for champions as well, right? I'm thoroughly convinced that AppSec Champions is just a way to punish developers for taking an interest in security, and I think there has to be a better way, and that's what we're going to talk about today. So I guess just show of hands, right? How many of you all are developers? Ish, one, okay. How many of you are on a security or AppSec team? Okay, all right. So hopefully everybody knows what the software development lifecycle is, right? There are many like it. This one is mine. We've seen 100 different variations. They all say somewhat the same thing, right? It's everything from requirements to design to coding, testing, deployment, maintenance, etc. I mean, we've tried to do a pretty good job as we move to Agile and DevOps of creating new SDLCs, right? And we've all seen the little infinity signs, and we try to wrap security around it. And many of us have probably even created some of those in our careers. But at the end of the day, right, we end up usually representing it linearly just because it's easier to talk about it. So let's talk a little bit about shift left, right? Let's make sure we all start on the same page. Traditionally, where many of us start with AppSec is with penetration testing, and that's still where the market largely sits today. In order to penetration test, our applications generally have to be live. Many of them have existed for many, many years, are very much in the maintenance phase of the SDLC. And so, right, we've all seen the scary pictures and the slides of how much more it costs us to find and fix vulnerabilities when the app's already deployed versus finding and fixing them early on, right? So this whole shift left thing is really all about how do we get from doing security, mostly pen testing, here in the maintenance, to ideally doing security over here in the requirements phase. And having secure requirements, right? I'm a big believer that security as code is going to save the world. But right, everything we normally talk about is all how do we do security at the requirements phase. So, right, this kind of ties into what Jeff said a little bit earlier too. As part of this talk, I decided to go out and just research, where did this whole shift left thing come from? What are its origins? What's its history? And what I found was it was introduced by Larry Smith in 2001 in a little article, which I've listed here. I was really surprised when I looked this up, right? I thought that I was going to find an article about pen testing and getting security into the requirements phase, right? We've all seen our vendors talk. They all talk about, hey, we give you an IDE plugin, right? This is shifting left. We're giving it to the developers. And that's really what we talk about today with security. Same thing, even if we talk Agile and DevSecOps, right? It's all about how do we take X tool and how do we put it into our DevOps or our CI/CD pipeline? And it's focused purely on automation. Well, this paper really surprised me because it wasn't about pen testing at all. It was written by a QA guy who was talking in 2001, 20 years ago, about taking QA test and doing security testing via QA testing and doing them earlier in the software development lifecycle, right? And this is a direct quote from this guy. Bugs are cheap when caught young. You can catch bugs earlier by making QA a part of your development, not just part of the release process, right? You know, go to any DevSecOps talk today, right? And that's what people like me are going to be telling you. So again, this really surprised me. 20 years ago, we had this idea right. So, you know, where did we go so wrong? You know, this is another quote, you know, directly from this article by this Larry guy. I'm not going to read all of this, but, you know, he's saying that there's downsides to this method in that your security work is going to go away. It's going to look like you're doing nothing, and you need to level set with management first to make sure that you don't get fired for being so good at your job. Which again is absolutely phenomenal how closely this ties in, you know, to what we talk about today with DevSecOps. So Josh, everybody loves shift left. Why do you hate it so much? Well, primarily, first bullet here, security responsibilities are given to developers without any thought regarding the impact, right? So we take complicated security tools that are designed for security people, and then we give them to the developers, and we expect them to use that, right? We go out and we buy training, right? I kind of got booed a little bit here 2 years ago at LastCon because I made the bold statement of AppSec training is not working, right? You know, SQL injection. We were writing books on SQL injection in 1995. I've given countless developer training classes. We're still making the same very, very basic mistakes, right? I kind of chuckled in Jeff's talk yesterday, for those of you that were there, when he was talking about instrumentation, right? And he did the SQL injection example where he said, okay, if you're using this method, and this method, that's bad, let's flag it, let's block it, right? And then he made the statement of, if you're using a prepared statement, let's let that through because you're secure if you're using a prepared statement. That's not true. We could use a prepared statement and we could use it improperly. I've seen countless times where, you know, developers just take a dynamic SQL query and they just wrap it in a prepared statement and they don't actually parameterize any of the queries. Well, guess what? You have zero of your protections at that point, and you might as well just be executing just a normal query. Shift left, in my opinion, has been poorly implemented. We're punishing our developers, right? You know, for those of you in security, I'm sure you've gotten pushback from your developers plenty of times. You know, why should I fix that? Hey, what the hell does CSRF actually mean? Can you even describe it to me? This tool is really hard for me to use. It's, I love to pick on, you know, like Secure Assist and similar tools, right? Because to security people, they sound absolutely perfect on paper. Hey, we can prevent vulnerabilities as the developer is writing them and just squash them in their tracks, right? But the end result of that, what we don't think about is that impact to the developer in that we are preventing them from writing code. I spent many years working for Ernst & Young, and we had this study that was all about multitasking. And the whole idea was nobody can multitask. And every interruption that we have that takes us off of a focused task, it takes the human mind 22 minutes on average to refocus on a particular task. So, you know, every email we read, right, we're losing 22 minutes of focus. This is why we all have ADD now. And so when we have these type of tools, right, every time we stop the developer from writing code, we're effectively eliminating 22 minutes of productivity. So again, getting back to this message of we're punishing our developers whether we're, instead of enabling them. And then, right, developer performance reviews do not include security, right? We love champions. We talk about scaling our AppSec program by taking developers and again, you know, punishing them. And part of that is we very rarely make security part of how they're scored and graded on their performance. So we want to tell them, hey, you know, you need to take, instead of doing 100% of your time on development and writing features and doing this cool stuff, you're not going to spend 75% of your time on that and 25% doing security. But oh, by the way, we're not going to give you a cool title, we're not going to give you a pay increase, and we're not going to change how you're reviewed and your performance criteria. So, you know, good luck meeting all your targets when now you have 75% of your time. So long story short, right? I think shift left is great conceptually, but I think, and getting back to Larry Smith's article, right? We had it right 20 years ago, but just went incredibly wrong along the way. So that's all great. Let's talk about solutions. I first ran across this concept of the Innerloop a few years ago. This was actually brought to me by one of my financial services clients who had, in my opinion, a very great idea, but again, they kind of translated it to shift left and went really wrong with it. So Innerloop, Innerloop, outer loop is something you can Google, right? A lot of this content came from Mitch Denny, who was a developer from Microsoft. And in his original article, this link won't actually work. You'll have to use the Wayback Machine because the site's no longer live. But he wrote a blog post that was talking about how they write code at Microsoft and using this concept of the Innerloop. Now, the Innerloop it's nothing I created. It's nothing Microsoft created. It's been used for a very long time. And everything from software development, project planning, automobile manufacturing, the list goes on and on and on, right? The only novel thing we've done here today is we've adapted it to work for application security. So what is the Innerloop? Essentially, and you'll have to forgive my graphics, I don't work at EY anymore, so I don't have cool designers, so I have to work on what the PowerPoint designer builds for me. So it's basically all of the activities that occur from the time the developer starts developing until they commit their code to a local Git repository. So everything that occurs after that push to the local Git is considered the outer loop. So basically, you can think of this as the developer's local development cycle. So to kind of help you see this visually, right? If we kind of break this down into a software development lifecycle, we have lots of inner loops and one outer loop. So here on the left, right? So I guess first of all, we've got pre-loop steps, right? Because there are security things that happen before we start developing. We talked about, doing security in the requirements phase, threat modeling, architecture reviews, things like that happen prior to development, right? I want to be clear that those are kind of out of scope for this conversation because they happen prior to any of the development actually starting. On the left-hand side, we've got the actual inner loop, which is what we'll be focusing on today. The inner loop consists of coding, building, testing, and committing, right? Nothing crazy here. We're not setting the world on fire. Here in the middle, right, we've got a pull request to push our code out to some other source code repository, into our Bitbucket or Azure or wherever we're storing our source code, right? And once it goes there, we enter what we call the outer loop. And then within the outer loop, right, just to kind of try to simplify this a little bit, right, there could be lots of inner loops, right? We're not writing waterfall, type code anymore. We've got a lot of developers writing and pushing a lot of code. So typically we're going to have, many, many, many inner loops that are going to be pushing code into this outer loop. And if we look at it a little bit more linearly, you've probably seen similar diagrams to this before, right? And I'm just trying to take a kind of an AppSec architecture here and just kind of draw the line on where the inner loop and the outer loop actually is. So again, nothing novel here, right? We've got our user stories and sprints up here in the top left. Right, once we've got our stories, which hopefully we have security stories too, we go into our threat modeling and architecture reviews. Hopefully we're doing that before we write code. Then we get to coding. Then we get to pushing our code to source control. Right? And then we get to our build system, right, which is where we do all of these other things that we hear about, everything from static analysis, right? We've got all of our automated testing. This is what your vendors are telling you to do. Hey, let's take all of our tools, let's put them in your pipeline, let's create bottlenecks to your release, all of this good stuff. But right, we've got our SAST, our DAST, our IAST, security as code, QA testing, whatever acronym it is you're using for all of your security testing. This is probably where it lives today, right? After you've pushed your code into your build system. And then it flows and, right, your flow probably looks a little bit different, but some sort of change management to get the code out there. All of these defects hopefully go to some sort of vulnerability management, maybe even Jira and giving that information back to the developer, short feedback loops, all of that good stuff, right? So right here, this green box at source control, where we've done that pull request to push our code, that's where the outer loop starts, right? If we get back to, this slide here, once we've got the pull request, we're entering the outer loop. So really the key takeaway here is probably most, if not all, of any security testing that you're doing today is happening here, and it's happening in what we're referring to as the outer loop. Right? And so what I want to convince you is to do security testing in the inner loop. So how do we do this, right? There's a couple of things that you need to understand about this inner loop model first, right? And this is where we tie this back to that developer enablement, right? So some key tenets of the inner loop, right, that have to hold true. First is the inner loop execution has to be fast as possible, right? Raise your hand if you think any of our security testing tools we have today are fast.
Mine is.
All right.
Most are not.
And what tool is that?
Now secure.
Now Secure? Okay. All right.
For this, we do what we call smoke test.
Okay.
Right? So it's designed to, in 5 minutes, can you give me a ready overview?
Okay. Now that's a fair argument. All right. And the second key tenet.
I can vouch that that's true. I've used that.
But I agree with you.
He didn't pay me to say that.
I came from other worlds. Yes, traditional tools are slow burns and generate a lot of gross output, right? They waste everybody's time.
Yep, exactly. And one of the things that we'll talk about is the QA testing aspect of that, which is where the smoke testing comes in, and kind of how that fits into both the inner and outer loop. And that is one of the things that we can do in the inner loop, as a minor spoiler. So the second key tenet is feedback time should be minimized, but quality optimized. All right, so again, right, you've all heard about the developer feedback loop and the amount of time from the time we test till we tell developers there's a problem to the amount of time that it's actually fixed, right? What Jeff referred to as the mean time to resolution. And finally, tax should be minimized, waste should be eliminated, right? What is tax? What is waste? Well, there's some handy definitions here that you can read, but essentially tax is any activity that does not provide customer value or feedback, right? It's a necessary evil, right? It's something that we have to do, but we need to minimize that. And waste is just like tax, except they're arguably unnecessary activities. So, if we think about those 4 phases of the inner loop, coding, building, testing, committing, there's only one of these that actually builds any business or customer value. And that's coding, right? Everything else, building, testing, committing, is just supporting that, right? It's not adding any value to what we do. But building and testing we have to do, and they provide feedback to us, right? If we try to build our code and it doesn't build, well, our compiler gives us feedback and says, so, dude, something went wrong. You've got an error on line 157. You need to fix it, right? Same thing with testing, right? Testing is all about giving us feedback about the code that we wrote. Committing is a necessary evil, right? It doesn't give us feedback. It doesn't really provide value. It's just a way for us to get our code from point A to point B, and it's something that we have to do, right? And the inner loop model would argue that that's a waste. So my argument here is that conventional AppSec tooling introduces large amounts of tax and waste. And just like real life, right? You don't want to pay a whole bunch of taxes. Same thing in Innerloop, right? So how can we do AppSec without creating a bunch of tax and waste? So what I'd like to do now is just kind of have some thought exercises. And when we started building this at EY, we had a lot of conversations around this because a bunch of smart people, people who've been consulting for 10, 20 years, right? Many of us, many of us came from Aspect security, working with bright minds like Jeff Williams and Dave Wickers. And EY actually bought Aspect Security in 2017, and we built out EY's AppSec program. So a lot of just very smart, founders of OWASP and such, working on this and just kind of thinking, okay, well, let's start taking some of these things we do in AppSec and just try to answer the question of, is it a good inner loop activity? So instead of saying, right, because the difference here is today we say, all right, well, how do we shift left? Cool. Well, let's take pick your favorite or least favorite SaaS product that has a developer IDE integration. So we're going to give it to our developers. Good job. We've shifted left. We wrote a wiki for our developers that they're never going to read. Good job. We've shifted left. But have we really actually moved the needle? We haven't, right? We've really just burdened developers. So let's talk about static analysis. So love to have some interaction here. Right, so using the concepts of tax and waste and the things that we've introduced today, do you think static analysis would be a good activity for the Innerloop? Any thoughts?
If it was fast enough.
If it was fast enough? Okay. Any other thoughts or opinions?
It generates a fair whack of false positive, false negatives.
Mm-hmm. All right.
I mean, I wouldn't in its current form because the majority of stack analysis focuses on finding lots of things all at the same time. If, from a conceptual standpoint, if you could look for one thing really accurately in that inner loop and do it, then it would make sense to do that one thing. That's not really how any of the commercial tools are structured. They're structured in an assessment-centric approach. If you could do it in an atomic approach where you're looking for one thing and you want to eradicate that one thing at a time, then that would make sense for the inner loop. But I don't think any of the tools today are organized that way to make it make sense.
Yeah, I'd agree with pretty much all of that, right? So, and again, there's no right or wrong answers to any of this. This is really just thought exercises. So I would argue static analysis is not a good inner loop tool, right? Because the long scan times lead to tax. False positives are an absolute waste. It takes considerable expertise to actually run the tools and configure them properly, which is an additional tax. We have the scan configuration itself, which is even more tax, right? So if we measure the amount of tax and waste that this tool would generate, I believe that it's not a good fit for the inner loop. What about DAST? Any thoughts on DAST? So kind of the same thing, right? So, DAST, first of all, it has to be a web app, and it has to be running, right? We can't just pull a ripcord on a source code repository or something and have it go out or take a look at our pull request. The app has to be deployed and configured and running, right? I love picking on DAST tools just because I hate the messaging around them and the way the vendors present them, right? I've been doing this long enough. I'm jaded on just about every tool. But when I talk about DevSecOps, right, and this is another talk, right? I think I talked about this here 3 years ago, right? I used to frame it as comms, right? Now I'm a big fan of the calmer methodology from the Scaled Agile framework of culture automation, lean, measurement, and recovery. And to me, I believe that all 5 of those key pillars apply to DevSecOps and AppSec at scale as well, right? And so if the only thing that we're doing with our tooling is automating it, which is what many of our vendors are doing, then we're only hitting one of those 5 key pillars of DevOps or DevSecOps, right? And again, getting back to this message of not adding a lot of value. And every DAST tool out there today now has an integration into the build pipelines, right? And they all advertise that it's a DevSecOps tool because we can scan your application as part of your deployment process. Well, most of the organizations that I've worked with in my consulting career are not at a DevOps level of maturity where they can do an automated deployment to an ephemeral server, and configure authentication and access control and things of that nature, right? And if you're not at a level of maturity where you can do that, it really doesn't make sense to have DAST even in your pipeline at all, because otherwise you're still just doing the same thing, which is configuring it to run against a static host with static credentials or something of that nature. We do have, compared to SAST, less waste in our output because the results of DAST are more accurate, right? So that is kind of a small plus to it. We do have varying scan times, right? I've worked with clients that had scan times of a week with DAST tools, right? And that doesn't make sense in anybody who says they're doing Agile. And the results can be inconsistent, right? That's another common flaw with these tools is you run a report once and you get a set of findings, and you run it again and the findings don't match from report A to report B because they're dynamically generating, the malicious input that it's sending into the HTTP request. So sometimes you hit these edge cases, right? Or maybe one time, it sends that perfect cross-site scripting test and gets a result, but the next 5 scans it doesn't, and it looks like you fixed the problem, but you really didn't. And so even if tax and waste were minimized, we've got to have the app deployed. So typically that's going to put us into the outer loop with DAST. Right? Manual pen testing? No, right? It's we're not anywhere close with manual pen testing. What about software composition analysis? Any thoughts on software composition analysis? Go ahead.
The best time to identify a poor choice is right after you made it, not 2 months after you started using it.
Mm-hmm. Yeah. So, kind of when we wrap this up here in a little bit, right, we'll see software composition analysis is an item that can exist in the Innerloop. My problem with it is that's not how most people are using it, right? Most of the tools that we have today, right, they're being deployed in kind of a scanning mode, where once a day or once a week or when a new CVE comes out, right, we configure white source, Sonatype, Black Duck, or whatever to go scan a bunch of our applications and tell us if it found that particular thing, right? We're running them very reactively. Another big thing with the SCA tools is it's difficult to determine the actual impact. And I hate to keep referring back to Jeff Williams' talk, but he made a lot of great points, right? And especially in my high maturity clients, particularly in the financial services space, right? They push back against these type of tools because their developers have been doing AppSec for a long time. And so when security comes in and says, hey, did you know this library that you're implemented has a CVSS score of 10 in this CVE in it, you need to update that. Well, developers are generally smart. They don't say, okay, cool, let me go take a month and re-architect my app or however long. They say, well, am I actually using the vulnerable library? Or the vulnerable code, right? And how many of you in this room have read a CVE before? Right, almost everybody. Most of the time, a CVE does not tell you how to reproduce the vulnerability, and it doesn't tell you where the vulnerable code is in the library, right? It's basically a black hole, and so you're telling developers that you have a problem in a library, and you have to go, and you have to patch it, and you have to update, but we have no way to prove to you whether or not you're actually using that vulnerable code, right? And in what world does that make sense? It really doesn't if you're a developer, right? So getting back to punishing our developers. We have had a lot of really cool innovations in these tools in the last year or two, but not a lot of people are using them, right? And this is where the Innerloop stuff comes in, right? So for one, a lot of these tools can now do kind of this real quick scanning as you make changes to your library, right? So if you go out and you add a line to your POM file, for your Maven build, or if you go get a NuGet library, a lot of these integrations can now say, oh, hey, did you know that library that you're pulling in right now, has some key concerns, right? Maybe you should consider using this version that doesn't have these issues, right? Would you like to do that instead? Yes or no? Cool, let's swap that for you, right? That can be very valuable. And also, some of the newer tools, right? And I love this, right? We'll actually do pull requests for you. So like SNCC has a new feature that's been added recently, where if you have SNCC, and it's kind of outer loopy, but if it's in your CI/CD pipeline and it detects a vulnerable library that has been pushed in that pull request, it will actually break the build, put in the new library for you, and then create a pull request and send it out for you to approve. And if you approve that pull request, it'll actually update to a non-vulnerable version of that library for you, right? Now, it's a little scary because, who knows what other issues that can introduce, kind of like I asked, right? You better make sure you have a high maturity in QA testing, if you're going to do something like that, right? So you can catch those issues if it does, bring in some unwanted features or something like that into your code. Security as code. Is anybody, I guess kind of show of hands, right? Who's familiar with security as code? Okay, not too many. So to me, security as code is really doing security inside of our QA test, right? It's kind of the simplified version of it. Again, this could be a whole nother conference talk, but to me, it's much deeper than that, right? Because it's all about how we take security requirements and make sure we're doing them, making sure we have them, having agreed upon security controls that can enforce and implement those requirements for us, the QA test case that then validates that that control has been implemented, and then the actual test case executing, right? So to me, this is part of the key of DevSecOps, right? This gives that traceability from requirements all the way to test to reporting, and most importantly, it focuses on the control as opposed to the vulnerability. So I love using cross-site scripting as an example of this, right? Because if a CISO comes to me today and ever asks, hey, can you say with confidence that there is no cross-site scripting vulnerabilities in this application? Right. Never in my career will I be able to say with 100% certainty, no, there are not cross-site scripting vulnerabilities in your app, right? I can say some fluffy stuff like, hey, we did a pen test and we didn't find any, or we ran a tool and we didn't find any, but does that mean that there's not any? It absolutely does not, right? But with security as code, we can agree with the CISO on a control that would prevent cross-site scripting. So let's say, just a library, or maybe whatever Microsoft calls it now, right? It used to be the anti-XSS framework inside of .NET, right? We can agree on compensating controls that prevent that vulnerability. Well, then we can use security as code to prove that that control has been implemented and configured properly. And validate that the developer turned those controls on and they're using them, right? And this has a lot of downstream benefits, right? For one, we're looking at controls, not hunting an endless list of vulnerabilities that we'll never catch up with. But further, right, if the CISO comes back and asks that question about, hey, do I have cross-site scripting vulnerabilities? I can look at the test results and I can say with confidence that we agreed on this control to prevent cross-site scripting, and I can show you with 100% certainty that this control has been implemented and configured properly, so we're theoretically safe from cross-site scripting. Right? And it also takes the burden off of some of these other things we do, right? If we agreed on a security control and we proved that it's there, do we need to test for cross-site scripting in a pen test anymore? Probably not. Right? Do we need to configure our SaaS tool to look for cross-site scripting? Probably not, right? It's just going to give us a bunch of false positives anyway, because it's probably not going to detect your library. So it's just going to be a lot more tax and waste. So that's kind of a quick intro to security as code. But to me, that's going to be kind of our lifesaver in the next few years with DevSecOps. So security as code, right? It can be in both the inner and the outer loop, right? Because if we think of QA testing, it depends on the type of QA test that we're doing, right? To your point about smoke test, right? If we're doing, unit test, functional testing of security controls, well, yeah, those can absolutely be in the inner loop, and the developer can run those locally. But a lot of our tests, integration test, end-to-end test, et cetera, typically our app has to be out, deployed, or, with all of its other controls out there, right? So that kind of, by nature, has to be in the outer loop. And then we can even execute these as a pre-commit hook. So, if we think about that shift from the inner to outer loop, we can use security as code as almost a quality assurance gate from getting from the inner loop to the outer loop. All right, so let's talk a little more about how we can actually use this in the real world. So first, I'm going to have kind of, again, my background being Big Four and EY. This is kind of my fluffy buzzword slide, right? So, performing security inside the inner loop drives a shift-left culture and shortens developer feedback loops to release code at high velocity by leveraging secure by design principles. And I would challenge you to find anything more buzzwordy than that here today. All right, Now again, a la Big Four, you're going to see some slides that have a lot of words and really crowded content here, right? But really what I want you to walk away with is that I'm not saying move to the inner loop, forget the outer loop, forget everything you've ever learned about shift left or anything of that nature, right? What I want you to walk away with is that the inner loop and the outer loop can work together, right? And we need to do testing and security activities on kind of both sides of that fence, right? So we want to focus on putting controls and testing into the inner loop where it makes sense, right? Because that's our most cost-effective place, right? As we all know through shift left, to do our security testing. But what I want you to do is think about it before you do it, right? Take that step back, think about the developers, think about how much tax and how much waste that you're introducing by putting that security activity into the inner loop, and then question if that's something you should be doing and how much value you're actually providing to your organization. Okay. And scalability, right? Outer loop testing is difficult to scale. Again, back to Jeff Williams' talk this morning, right? We've only got so many tools. They have a lot of problems. We only have so many security engineers, only so many AppSec unicorns, only so many champions, et cetera, right? And everything we do in the outer loop is going to cost resources, regardless of whether that's, an engineer to integrate it into our 700 pipelines, or creating a bunch of Jenkins files that the developers are going to delete or change anyway, or, even just impact to our pipeline, right? Because every one of these tools we put into our CI/CD pipeline introduces a bottleneck. So any of those that we can do in the inner loop, right, we can start removing those from the outer loop. And then we want to empower development teams. So again, getting back to developer enablement. When the secure path is the easy path, right? I'm a big believer that it's the path that will be followed. However, we as security practitioners often make the secure path the most difficult one, right? To the point where developers are trying to disable our tools or take them out of their pipelines, or they're questioning our results, right? Because we're introducing impact to them, often without any value, right? So again, back to our analogy with software composition analysis, right? We're asking them to spend time fixing issues that actually aren't an issue at all, right? And then we kind of get all pissed off when they push back at us and don't want to fix these problems, right? One of my favorite interview questions, that I ask every single person that I interview for my organization is around SQL injection, right? And we talked about parameterized queries early on in this talk. And the question I always ask them, especially in pen tester roles, is, right, assume you've done a pen test and you found a SQL injection vulnerability. And you're sitting there at the readout table with the development team, telling them about all these problems you found. You're beating up their app, their baby. And then you tell them the same thing, OWASP, or that we've said for 25 years, right? Hey, I found a SQL injection problem. You need to use a prepared statement, parameterized query to fix this, and you're good. So go do that and have a good day. Well, what if the developer says, well, I'm not dumb. I took that training class. I read that OWASP site. I'm using a prepared statement, right? Well, as the pen tester, what's your response to that, right? And the vast majority of the time from pen testers, they jump to an answer like, well, I'm going to pull up SQL map right there in front of them and turn my computer around and show them that I exploited it. So they're not doing that, right? And it automatically turns into a combative situation. Right? And really the answer that I'm looking for with those interviews is for somebody who can think outside the box, right? Who understands this stuff at a deeper level than just a quick OWASP article. Because the obvious answer is they didn't use that prepared statement properly, right? And I've seen this time and time again in organizations, right? If you're not actually parameterizing those inputs, that prepared statement does not fix SQL injection. Right, so I'm looking for pen testers who can take that step back, right? Try to work with them to figure out what they're doing wrong, and then help them fix it, right? As opposed to immediately turning it around into a combative situation. So inner loop testing, right? To do inner loop right? Think about self-service security. Right? We're doing this fairly well today, right? A lot of organizations have been embracing self-service security for a very long time, but take it to the next step, right? And make sure that the tooling is fast and it's accurate, right? And that's not something we do a very good job of today. Secure by design, right? This one's kind of a free space, right? If you're doing secure by design, you're pretty good here. And then rapid developer feedback loops, right? So the quicker you get this information back to the devs, right, you're better. Outer loop testing, focus on automation first. But again, don't forget about all those other letters within comma as well, right? Make sure that your tests are lean, that you're actually measuring things, right? That you're actually driving culture, and it's not just automation for the sake of automation. Focus on depth and rigor, right? We can't get depth and rigor in the inner loop. Do it in the outer loop instead. And then security control testing. So again, in your culture, focus on, really just the shift away from, how many vulnerabilities can I discover to, what are the security controls that we need to have in place? Right, because we've all run static analysis tools before. I've run them and they come back and say, hey, you have 60,000 vulnerabilities. Then we've got to triage them. We put them into a PDF report. We give them to people. They never fix it. Maybe even worse, we've listened to some DevSecOps talks before, and we try to take those 60,000 vulnerabilities and put them into their JIRA system and tell the developers that they're defects and to fix them, right? And again, we're not enabling developers at that point. We're pissing them off. But at some point, we have to stop chasing vulnerabilities. We're never going to win as long as we're chasing vulnerabilities, right? So we need to have this paradigm shift where we start thinking about security controls, how to implement strong controls, how to validate that they're there, and then report them in a way that makes sense, right? And a great example of this is cross-site request forgery. Cross-site request forgery, for one, most people can't explain what it means anyway, let alone to a developer. So every time we put it into a report, we probably put it as a low, right? And the CISO says, hey, what's this CSRF thing? Why is it a low? What's it mean? I don't know, but it's a low, so you don't need to fix it anytime soon. Right? That's what I've seen time and time again throughout my years in consulting. Well, did you know if you have to comply with PCI and you have a cross-site request forgery vulnerability in your application, you are not in compliance with PCI? That's pretty scary, right? So now, instead, when we have that conversation with the CISO, if we can present this data in such a way, to show that, hey, we've got the CSRF thing and we can't really explain it to you, but now it's a critical and it's a red on this PCI report because we're not in compliance with PCI, so we really need to fix this. Guess what? You're going to get the support to squash that vulnerability and hopefully figure out how to get some anti-CSRF controls throughout your applications. All right, so what tools do look good in the outer loop? Right? And this is going to be all the stuff that you already know, right? This is all the tools that you're already using today, right? Static analysis, again, great tool in the outer loop, poor tool in the inner loop. Same thing with DAST, right? Software composition analysis, right, there is some inner loop functionality there, but today it largely exists in the outer loop. Even IAST, right? We've heard for a long time that IAST is going to save the world, but to really get value out of a lot of these IAST tools, right? We can't just go out and buy an IAST tool and dump it into our environment and scan and get good results, right? They rely on instrumentation and they rely on us exercising the application and calling that functionality. So in other words, we have to have strong QA testing, within our applications in order to have good results from IAST, which, again, take something new and cool and innovative like IAST and kind of puts it firmly into the outer loop. And then manual pen testing, right? It's a manual activity. It's always going to be in the outer loop. So what are some cool things that we can do in the outer loop or in the inner loop, to kind of move the needle on our program and make things at least a little bit better for developers? So these are just some of the things I've come up with. You might have more. Again, this is a thought exercise more than anything, right? I don't want you to walk away and say, hey, I need to do all of these things and implement them today, but just whenever you're thinking about introducing a new tool or a new process or anything into your security program, to just step back, think about this inner-outer loop, and think about the impact that you're going to have to your development teams, and then make the decision based on that, right? That's what this is all about. But git commit pre-hooks, can be a great inner loop activity, right? That doesn't mean take all of these outer loop things and cram them in as a pre-commit hook and execute them before that pull request, gets accepted or whatever, right? Lightweight testing generally, those smoke tests, those QA style test cases, right? Those very fast, accurate, millisecond, QA test that we can run to validate controls at that point. Right, lightweight software composition analysis. So we talked about how we do have, some of these products now are introducing features where they can test, so they look at your POM files when you drop a new library in there, your NuGet, Chocolatey, NPM, whatever it may be, right? And when the developer makes that change to that configuration, let them know at that time that they have introduced a library that may have a vulnerability in it and that there is a safe version available that they can use, right? We're not introducing tax, we're arguably not introducing waste, and it's a change that they can make immediately without having to re-architect their app, hopefully. Continuous security linters, spell checkers, right? To be clear, I don't think these tools are here today, right? Getting back to, our earlier messaging about, taking the developers out of the moment, losing 22 minutes of productivity every time we interrupt them, while they're writing code, et cetera. But I do think there's future here, right? We've come a long way with just kind of, machine learning and, autocomplete type of stuff. In Gmail now, I can pretty much open Gmail and hit tab 12 times and have a pretty bloody good email that I can just hit send, and I didn't have to write any of that myself, right? It just did it all for me. GitHub has, I don't remember what it's called, right? But they have the new autopilot thing, where it's, going to save the world and write code for you, right? And I don't think we're seeing that yet. We're seeing it do a lot of weird things, but there's a tremendous amount of potential there. So, I think as vendors kind of pick up on this and write tools that can, do, things like, SonarLint, Secure Assist, those type of tools, right? As those tools mature, get better, and can actually make, quality recommendations without interrupting the developer, this could be a fantastic Innerloop tool. But again, I don't think we're there today. Every organization I've worked with that has used those tools, the developers have fought them and disabled them because it's too impactful. And then security as code. So again, getting back to that lightweight, QA testing of security controls. Again, not scanning for vulnerabilities, not running scanners, but instead a QA style test to validate if our agreed upon controls are in place. It is another fantastic introduction to the Innerloop. So in conclusion, right, couple takeaways here, right? So first of all, there is no right amount of tax and waste. This is going to be different for every organization, right? And you'll have to work with your teams to figure out what that right balance is for you, right? A lot of my background has been in working with large financials. And a lot of large financials have no problem saying all of our developers are going to run SaaS and they're going to get over it, and that's an appropriate amount of tax and waste for us, right? So, just know there is no right or wrong answer. Work with your teams, figure out what's impactful and what's not. And always, focus on reducing that tax and eliminating waste, right? So if you have wrote out a tool, if you are using them today, start to think about that impact that you're having on your development teams and what you can do to make those tools easier to use, faster, more reliable, right? Picking the right tool for the right job. And security as code and things of that nature. And when you pick that right tool for the right job, you're going to be minimizing that tax and that waste. And then again, continuous improvement, we talk about a lot in any DevOps talk, right? And from a DevSecOps perspective, continuous improvement is going to be equal to continuously reducing that tax and waste. And your developers are only going to be thankful that you're taking some of these painful things away from them. So that's all from me. Any questions, thoughts? Is this garbage? Good thinking? What do y'all think? Awesome. All right. Well, thank you very much for coming, and I hope you all enjoy the rest of your time at LastCon.